Hi, everyone. Um, so this is my math concepts plan. Grade level is second grade, and the focus of the lesson is fractions, specifically standard CC 232A2. Use understanding of fractions to partition shapes into half, quarters, and thirds. By the end of today's lesson, students will be able to apply their understanding of whole real-world objects being segmented into halves, thirds, and quarters by partitioning 2D shapes. So this is the guided practice from Envisions 2.0 13.6. As you can see, it goes straight into the abstract in order to give these definitions up here. And then for the guided practice, students are mostly tracing and copying. So I thought that some work could be done here. For my critical analysis, I said within the guided instruction portion of this lesson, the main goal of the lesson is to explain that in order to be considered half, third, or quarter of the whole object, each part must have equal shares, which builds from the prior lesson. The guided practice, the students trace each way a square could be broken into half, and then students are prompted to determine which segmented shapes are either half, thirds, or quarters. These vocabulary words are explained in the visual learning bridge, where it shows examples and non-examples, as well as gives definitions of each. This does give an explanation of the concept, but is not considered a deep explanation, as students are expected to simply remember and memorize these vocabulary words. Students are then expected to partition a rectangle into thirds and answer how many thirds are in the rectangles they've drawn. The textbooks includes many representations of the various ways to partition rectangles and circles by halves, thirds, and fourths within the guided practice. And then within the guided practice, there is no examples of deep questioning. Additionally, guided practice does not include or does not connect this concept to the real world. This would be a good time to introduce real-world objects that can be partitioned into halves, thirds, and quarters using a model such as pizza or sheet cake, which could connect these abstract concepts to the real world, in addition to making the guided instruction meaningful for the students. So how I went about that in my modified plan, I created an anchor chart, which is essentially the same as the visual learning model at the top. But then I'd also bring in a sheet of brownies because that would get the kids so excited. So on the projector, on the smartboard, I would put the brownies on the projector, and I would show some non-examples of halves, quarters, and thirds. My effortful thinking question would be, why is the share not considered 1/2? And I would repeat this with thirds because Ms. Furter wants a piece, fourths because Mr. Sablota wants a piece too. And then students would segment their whiteboards as a formative task. So yeah, and then from there, if you look at this convince me, show this rectangle has with 3 equal shares, how many thirds are in one share, how many thirds are in the whole rectangle. I thought we could make that a more effortful thinking question. So this is how I did that. For the convince me, I said, show students that we can cut the rectangle into 3 different shares and have the students come up to the board to shade in one share, write 1/3 underneath, have another student shade in another share. How can I represent that over 3? Turn and talk. My feedback, I would confirm and ask a follow-up question. So yeah, we could write 1/3 because it's 1 out of the 3 shares. My effortful thinking question that I follow up with, but what if I'm keeping these 2 shares for myself and you are only getting 1? How could I represent that over 3? So that requires a student to apply and analyze what they've learned before. So 1/3 is 1 share. And it's a little bit of a a formative struggle, I'd say, but I think the students could get it. So how could we represent that over 3? Confirm or correct. We could actually represent my 2 shares as 2/3 and your 1 share as 1/3. From there, I would have another student shade in the last share, have them label it as 1/3, and then I would ask this question. Let's say that 2 friends really want a piece of this rectangle cake. So I cut it into into thirds. But they had to leave before they could eat it. So now I get to keep all 3 shares for myself. How would you represent that over 3? So again, this goes into answering this question up here. How many thirds is the whole rectangle? Well, the answer would be 3. There's 3 thirds, but this also puts fractions to it and helps better explain why the answer would be 3. And so feedback, confirm, or extend. 3 over 3, I would get to keep all 3 out of the 3 shares. In other words, I would get to keep the whole rectangle cake for myself. So again, I go into more detail for the independent practice and problem solving portion of the textbook, but I thought this was a great example of how I would first go about modifying the plan in the guided instruction, because this is, in my opinion, lacking a lot of the things necessary to have students grasp this concept. Anyway, thank you guys. I'm excited to hear your feedback.